Radio TV phono nut here, and we have a cardboard cased Symphonic one-tube wonder kitty phonograph from 1965. I wasn't even going to do a video on this, but what I saw on the inside I think you'll get a kick out of, and I want to illustrate a point with this video. When I got this, the screws were half backed out like they are now, so that tells me that somebody's been messing with this. And when we turn it on, it's stone cold dead, not a thing. And this is one of those models that has the 25-volt tube heater wired in series with a 90-volt phonograph motor, so it shouldn't be too hard to find out what's the matter with it. But before we dig into that, let's lift the motor board and show you what I found on the inside. Here's the schematic that they were nice enough to give. And as you can see, not much to this at all. It's about as minimal as it gets. And even with a 3-volt crystal cartridge, this one's not going to get all that loud. And I think they designed these on purpose so children playing their nursery rhyme records and whatnot wouldn't blast everybody else out of the house without listening to them. Alright, here's the underside. And the first thing we notice is some, it looks like the speaker wiring has been cut and respliced. In fact, this speaker might be a replacement. I don't know. It's riveted into place, but whoever replaced it might have riveted the new one in place too. So I want to correct this. But that's not the good part yet. Let me pull this cover off and show you the good part. You'll love this. Here we are with the cover removed, and as you can see, someone has already attempted to repair this. You can see they replaced the filter capacitors and glopped them up with silicone to hold them to the chassis. And we have some pretty sloppy soldering here, and I really love how they used a zip tie to secure this black negative lead to this hot power resistor here. That's a definite no-no. And here's another zip tie down here. So that's what I wanted you to see and bring up a couple of points. And here is my theory as to what took place here. Whoever worked on this was inexperienced with electronics. They fell into that replace the caps and it will magically work way of thinking. So they replaced the capacitors, and then when it still didn't come to life, they didn't know what else to do with it, so it ended up getting donated to Goodwill. And theory number 2 is it might have exhibited some signs of life before they worked on it, and then they did this and ended up making a mistake somewhere along the way, and now it does nothing at all. So we need to clean up this mess. But before we do that, let's try to find out why it's totally dead. And one other thing, they used 160 volt capacitors here. I'm sure the original can, well, we can look here shortly because it's still there, was probably rated for 150 volts. Now, when you're replacing filter capacitors in a set with a solid state rectifier, whether it be selenium or silicon, you probably want to use, in the case of equipment like this, it does not have a power transformer. If the original capacitors were 150 volts, you probably want to go with 200 or maybe even 250 volt capacitors. And the reason being is because the 150 volt rating on these old capacitors, that was the working voltage. And it was a given that these had a surge voltage rating that would take a momentary surge to up to say 200 volts without damage. These newer capacitors, when they're rated for 160 volts, they mean it. 160 volts is the most they ever want to see at any given time. And when you turn on this equipment, the B plus is going to ramp up to over 160 volts until the tube warms up and starts conducting, which loads down the power supply and will bring the B plus down to about 120, 130 volts or so. I learned early on about this whenever I had a 160 volt replacement cap pop on me because it couldn't take the surge voltage. And after I replaced the capacitors with 200 volt jobs, then everything was fine. Okay, so let's get our meter, set it up to measure voltage, and we'll connect the negative side of our meter to circuit ground here, and then we'll find out what's going on. I have my meter set up to measure AC volts, and we have the negative side of the meter connected to circuit ground and the positive probe of the meter connected to where the AC enters into the selenium rectifier. Now I'm going to switch the power on here and see if we get any AC going into the record player. And we have the switch on the record player turned on. So let's turn on our isolated AC power supply. And we have absolutely no AC voltage going into the selenium rectifier. So that suggests that either the switch is bad or the AC power cord is bad. And a simple ohm meter test will determine what that is, what the problem is. And as it turns out, looks like the power switch is defective. Reading, well, now it's going to read. Wasn't reading before. Alright, let's spray some contact cleaner in here and see if we can save this switch. I really wouldn't want to have to replace this potentiometer and switch combo if I can help it. So let's see if we can get some cleaner down in there and persuade that switch to work. Okay, now we have zero continuity across the power switch, which is what we want. So we're connected back up to measure the AC voltage going into the selenium rectifier. So let's retest and see if we get anything. Yes, we do. 123 volts, and obviously the turntable motor is turning now. Now I want to let this warm up and see if I get any activity from this cartridge. Okay, I'm not getting anything when I rub the needle, and I'm also not getting anything when I touch the audio input to the volume control. So now let's set our meter to measure DC volts and check some voltages here. All right, now the meter is set to measure DC volts, and we're going to measure our B plus at the cathode of the selenium rectifier. So let's turn it on and see what we get. We jump up to 160 volts. So let's let the set warm up. And as you can see, it's dropping rapidly. We're down to about 105 volts now. Alright, let's check our voltage on the other side of that resistor. The resistor is getting warm, so that tells us current is being drawn through it. So let's move our DC voltmeter to the plate of the audio output tube and check that. Okay, 165 volts, and it should drop once the tube starts conducting. So that tells us that the primary winding on our audio output transformer is good. Yeah, 84 volts on the plate. Like I said, this is not going to be a very loud record player, even with a hot 3-volt crystal cartridge. Alright, let's check our screen voltage. Alright, here's our screen grid, running about 77 volts. So that's okay. Now let's check our cathode voltage. And with a 47 ohm resistor, it's not going to be that much. Alright, 2.6 volts. So we have a little something there, but not getting any buzz whenever I touch the input to the volume control. Now I want to check these speaker wires that someone spliced together, because it's highly possible there's an issue there. And just as I was afraid of, these wires have an enamel coating on them to prevent short circuits. And it's obvious that whoever spliced these together failed to sand off the enamel coating. They just simply wrapped the wires around each other. So therefore, no audio is getting to the speaker. So let's fix that problem. But while we have it loose, I'll go ahead and check the continuity of the secondary winding of the audio output transformer as well as the voice coil, and if all that's good, then we will connect everything up properly. Right, voice coil 2.9 ohms, that's about what I would expect. And I scraped off the enamel and tinned the leads there coming out of the output transformer, and we're reading basically a dead short, which is about what we want. So we'll connect this to our speaker and hopefully we'll have audio. Alright, speaker is connected properly now, so we'll re-energize this and see if we have any audio from the amplifier now, or more precisely from the speaker. Right, I'm hearing a hum from the speaker. It hummed from the speaker, but nothing when I stroke the needle. So let's look at the cartridge and make sure it's not disconnected, and we'll check it to see if it has any output, and I won't be a bit surprised if it's stone cold dead. Alright, this is a Varco, or Vaco as some of them are labeled. High output crystal cartridge. It's not the turnover type. You have a single-sided, either a 0.1 or a 0.7 mil micro groove stylus by 65. I think they were putting 0.7 mil stereo compatible needles in these. You still had 78 RPM, but no 3 mil needle to play the older type 78s. I think by the mid 60s that they figured that the only 78s that would be played would be the newer micro groove Kitty 78s. And by the early 70s, the 78 and 16 speed started to disappear from these types of phonographs, except for a few later ones that used a 3-speed BSR mechanism. But for the most part, 78 was gone by the early 70s. Alright, let's get this cartridge out and check it. And as we can tell, our positive lead is broken off from the cartridge connector, which is a common problem with these. So I'm going to pull the cartridge, check it with my AC voltmeter, and if we have output, then we'll reattach that connector and put it all back together. If we don't have output, then we'll have to decide what we're going to do at that point. These 3-volt crystal cartridges are getting hard to find, and when you do find them, they're usually expensive, generally a lot more than what the record player is worth. Alright, Vaco SN55, made in Japan. Very common Kitty record player cartridge during the 60s and 70s. And as we can tell, the needle is all jacked up, and the suspension, it looks all jacked up too. So I'll be surprised if this has any output at all. As you can see, I'm rubbing the suspension, I'm stroking this cartridge's ego, and it does have output. It's actually kicking up there to over 3 volts, so we might can use this. I just need to find a needle here that's not bent. And I was able to successfully straighten that needle, so we'll see if it'll work. It looks like it's still got a point on it. Don't know how good a shape it's in, but at least it has a point. Now let's repair this broken cartridge connector, and hopefully we'll be able to play a record here shortly. Alright, the cartridge connection is repaired. The cartridge is back in the tone arm. Let's see if we can play a record on this now. Well, if our outlet will cooperate with us. And yes, it's working. Doesn't sound that great, but I didn't figure it would. Something that won't likely get us in copyright trouble.
Good morning to my friends. Good morning
And that's wide open, and this is the kind of material that would have probably been played on this whenever it was newer. Either that or those read-along book record things. When you hear Tinkerbell ring the chimes, you'll know it's time to turn the page.
Started off with the body shake.
Okay, it's working good enough. So now we're going to clean up the amplifier. Had this cartridge not been good, or had it not been usable, I'm not convinced that it's 100% good with that deformed suspension, but it works. But had the cartridge not been usable, we would have had to heavily modify the amplifier to have a preamp stage to allow the use of a modern lower output cartridge. But since this cartridge works, we're going to keep the original circuit design and clean up the mess that was made. And then of course, that drive mechanism is going to need some help too. So now we're going to pull all of this off, and we'll check the resistors, and if any of them are out of tolerance, we'll replace them. And the next time you see this, it'll be a lot neater looking. And one other thing, the camera's not going to focus, but the way they have this connected with no insulation on the leads, and the way these leads are able to easily bend, these could very easily short together, and that's when you have smoke and fireworks. Alright, all these resistors are out of tolerance, so go ahead and get rid of them while we're here. And I plan to mount the filter capacitors on this terminal strip, which I will have soldered to the chassis here. But I won't do that until I replace the resistors, because it'll be easier to replace the resistors without this in my way. So we'll go ahead and do that, and then replace our filter capacitors. Alright, we're getting there, but a couple of things I want to show you. These terminal strips, they've been around a while, so before we could use them, we had to scrape off the oxide, and then I cleaned off what was left with some rubbing alcohol. Failure to do that will result in a solder connection that will not stick. The solder will just ball up and fall off. It just will not stick. So we cleaned that up so solder would stick. And then we're going to use these two center terminals for our ground. So you see what we've done. We've ran our black ground wire through the bottom eyelet, ran it through here, ran it over to this one, soldered them together so these terminals are common ground. And then for our red one, we ran that through right here, ran it up through the top eyelet, bent it over and crimped it to get a good mechanical connection. I have not soldered that yet, obviously. And we did the same thing to the blue one, and right now it's just soldered enough to hold it in place. And then we scraped off the chassis to get it good and clean, and then once we have everything soldered, we'll solder our terminal strip to the chassis there, and it won't go anywhere. Well, I think my work looks a lot better than theirs, don't you? So we put a terminal strip here, mounted our filter capacitors to that. We replaced the resistors that were out of tolerance. Now obviously the old ones weren't out of tolerance enough to cause total inoperation, but I want to just go ahead and get rid of them just so I wouldn't have to worry about it later. And I moved our chassis isolation capacitor from right here to right here, between ground and our lug on the terminal strip that solders to the chassis. The only thing I have not done is replace the selenium rectifier, and I may not replace it. Right now I'm monitoring our B+ voltage at the first filter capacitor, 91 volts, and I'm going to let it stay on for about 10 minutes. And if the rectifier doesn't get overly hot, or if the B+ doesn't start dropping, then I'll probably just leave it alone, because this is not one I'm going to be using on a regular basis. Now if this was one I was fixing up for somebody, I'd probably go ahead and change it. But if this shorts, it'll burn open this fusible resistor here, and we're still hanging at around 91 volts. That's what we want. Yes, this took a little longer to do than what it probably took him to do what he did, but it looks a lot better. I mean, I'm not going to talk about whoever did it too terrible, because this could have been a young kid that didn't really know any better. I'll have to admit that whenever I was a young teenager, I did some pretty sloppy things too. Much of it was done on my bed. My bed was my workbench for a while there. And then I was allowed to use the kitchen table, but it pretty much all had to be gone by the time supper was ready. So that was a bit inconvenient, being in the middle of working on something and then having to clear off the kitchen table for meal time. And then I got this building that I'm in right now, and that was a major step up. The only thing I'm gonna say is, when you have people who choose to take shortcuts even though they know better, but they choose to take shortcuts just to save time. And I'm not really about saving time. The way I look at it, this stuff probably hasn't worked right in decades, and it's not going to hurt to take a few hours or a few days or a few weeks or a few months or whatever to do it right. Now, there was one resistor in here that I had to J-hook because it wasn't long enough. The leads were not long enough, but you see what I did there, I hope. As you can see, I ran insulation over the remnants of the old resistor lead, and then I ran insulation over the new resistor lead, and then before I joined them together, I ran a larger piece of heat shrink tubing over the resistor, and then once we soldered the connection, I slid the heat shrink tubing over the connection and then heated it to shrink it down to size, and now we have a fully insulated connection. And as you can see, I insulated all of the leads on these resistors that I replaced. There was a 1 meg here from center of the volume control to ground. It reads 1.2 meg. I didn't bother with that one. That one's not a critical resistor, but the rest of them were out of their 10 to 20% tolerance ratings, so I went ahead and got rid of them. And we're still holding at 91 volts. And this rectifier is just barely warm, which I would anticipate for a good one. Now, there is a considerable amount of voltage being dropped across it, so yes, it is going to generate some heat. But I think this rectifier is just fine, and I'm probably just going to leave it alone. Like I said, if it shorts, it'll just burn this resistor open, and there'll be a metal cover over this to prevent any after effects, as in if something should flame up, from reaching this cabinet here. However, this resistor is a bit warm to the touch. The one they had the negative lead attached to with a zip tie, and this is after it's been off a couple of minutes. If this thing was left in operation, it would get pretty toasty. It's 220 ohm. What is this? 2 watt? Yeah, 220 ohm, 2 watt looks like. Now, these selenium rectifiers, they have advantages and they have disadvantages. The disadvantages are, when they short, they usually emit a very foul odor that can be toxic. And usually when that happens, the carbon surge current limiting resistor that's attached to it will go up in smoke and flames. I've seen the evidence of that before. However, the advantages to these is, because they have a high internal resistance, they're more resistant to things like power surges and lightning strikes, whereas a silicon diode will short if you look at it funny. If you don't believe me, ask anybody that was in the TV repair business over the past 40 or 50 years. Can't tell you how many televisions that I fixed where lightning or a power surge would hit them and short out one or more of the silicon diodes in the bridge rectifier network. And I learned when that happened to go ahead and replace all 4 of them, because more than once I've replaced the 1 or 2 that were bad, and one of the remaining ones, even though it would check good on a meter, as soon as voltage would hit it, boom, it would short. So just better to go ahead and replace all 4 of them. Silicon diodes are cheap enough. But yeah, I think we're going to leave this alone for now. Alright, cover's back in place, and the terminal strip for the filters is recessed far enough down in there that there's no chance that those terminals will ever short out to this cover here. Alright, now we need to do the mechanical overhaul, and then we ought to have us a working Symphonic Record Player from 1965. And I'm going to go out on a limb here and say that whoever worked on this did not remove the turntable platter for any kind of service, because if they had, this would have likely been easier to pull off. When they've been on here for 50 or 60 years, that's when they're a pain in the butt to pull off, and you have to tap the spindle with something to get it to break loose. In some cases, I've had to grab the spindle with vice grips and then rotate the platter to break it free. Alright, it's pretty clean in here, but as you can tell, some lubrication is going to be in order. And these motor mounts are kind of hard and on the verge of cracking and breaking, so I'm going to replace those too. Take the motor apart, clean it and lubricate it. Take this spindle out, clean it and lubricate it. We'll use our zoom spout for anything that needs oil and anything that needs grease. We will use our, where is our tube of grease? What happened to it? You know, probably can't find it now that I need it. Anything that needs grease, we'll have a date with this super lube here. On the spindle, I usually clean all that out really well. Put a layer of the super lube on it, and then put a drop or 2 of zoom spout on it to mix in with it. Put the spindle back in, put the clip back in place. The motor gets taken apart, cleaned out, and lubricated with zoom spout. We use Q-tips and paper towels and 90% isopropyl alcohol for that. These areas here that slide, that'll get cleaned up and a layer of super lube put on that. The idler wheel will be taken off, which is held on by this clip. That will be cleaned up with isopropyl alcohol. Put a drop or 2 of zoom spout on the shaft, put it all back together, making sure not to lose any of our washers, and making sure that there's no oil or grease on the surface of the idler wheel or the motor shaft or the inner rim of the turntable. In fact, usually what I do after cleaning a motor before I put the wheel back on is I'll power up the motor and then clean the shaft with a paper towel dampened in rubbing alcohol to get rid of any dirt and grease that might happen to be on there. And that ought to about do it. If you need one of these idler wheels, I think the correct part number for this one is 1490-01. They're not made anymore. Your only options are to have them rebuilt. It's about 30 bucks plus shipping. But I think this one I can probably clean it up and use it. It's got a little bit of a dent in it, but for what this is, that's no big deal. Alright, we're almost done here. I've taken the motor apart, cleaned it and lubricated it, cleaned the center spindle, replaced the motor mounts. Now on some motors, most motors, there's a spring that fits over this bottom rung on the motor capstan to increase the diameter of the motor shaft to where it will turn at the proper speed for give us 78 RPM. This one doesn't have the spring. I've seen some cases where the spring was just never there to begin with, and I've seen other cases where the spring would, for whatever reason, have been removed over the years. We won't know that until we try to play a 78 and it runs slow. If it runs slow on 78, we'll know that we need to dig around in our junk stash and find a spring somewhere. And here we are back together, almost. Good torque even on 16 RPM, so alright, let's find some records and see what we got. Here's a 78, even though this is not the right needle. That sounds close enough, so we don't have to worry about finding a spring. That's good. And that actually gets pretty loud, louder than I figured it would. As far as I'm concerned, about all I need to do with this is replace the needle. Somewhere I have some of those Fan Steel 700 needles. I just got to find them, and then I will replace that, because I'm sure that's a sapphire needle and it's more than likely worn out. Now, as far as playing 78s, the only way we could get away with that is to replace that needle with a 700 S3, but then that would knock us out of playing the other 3 speeds. Or I could replace that needle with a 700 S2, which is a in-between size between a 0.7/1 mil and a 3 mil. It's supposed to be an all-speed needle, but in all actuality those don't do very good for anything. I guess they're okay for kiddie phonographs, but wouldn't be a good idea to play stereo records with a 2 mil stylus. Or like what's on here, I could just put a 0.7 mil or a 1 mil and only play micro groove records. But no matter what needle we choose, something like this is not what you'd want to play your best records on. You know, with the right needle it would be fine for 78, but not for your good LPs and 45s. And the stuff that's like this, it's already beat to heck and worn out, then yeah, no real harm there. But I wouldn't be playing my mint condition prized possession records on this.
Well, what do you think about a stormy day? Oh, no umbrella, it might blow away.
You can hear how worn out that record is.
Stormy day. Oh, no umbrella, it might blow. Swing, swing, swing.
This record was in a stack that I got when I bought that Caliphone record player at the flea market a number of years ago, the one that came from my elementary school. And this record is from when? Come on, focus. Hang on. 1989. It's pretty maxed out for a record that new. But knowing that a lot of these school records were played on Caliphone record players with worn out needles, or needles that were flipped over to the 3 mil 78 side when the LP side would wear out, I found that these schools were not very adept at changing the needles on those things. It pretty much had to get to the point where it would not track a record at all before they would change the needle, and most of those needles were sapphire, so they didn't last all that long, about 80 to 100 hours, and that was about it. And one other thing, just in case you don't know, when you have a record player like this or a school phonograph, and when you're not using it, always place the speed selector in neutral. That prevents the idler wheel from developing a notch from resting up against the motor shaft for too long a period of time. It's not marked on this record player, but neutral is between 33 and 45, and that's usually the case for the General Industries motors. The Alliance motors, the neutral is usually past the 78 position, and if your model doesn't have a designated neutral position, usually setting it between speeds will place it in neutral. But yeah, we're good to go now. We're back together and ready for another 50 years of use. As far as cleaning these up, be very careful, because the covering on these later kitty record players is usually very cheap and very paper thin. If you get too aggressive, you'll tear it. In fact, it's been my experience, when this type of covering gets soiled, then there's really not a lot you can do about it. That's pretty much the reason I only pick these up if they still look presentable. And if they don't look presentable, about the only way I'll pick them up is if they're cheap enough that I can use them for parts. But this one looks pretty presentable, and I'm not going to press my luck. I don't want to mess this covering up, so we're probably going to just leave it alone.
And Mildred Norton. Copyright 1964
16
by Alfred
RPM
Enright
record.
and Mildred Norton. Recorded for the Library of Congress in the Talking Book Studios of American Foundation for the Blind Incorporated, with the kind...
And I can tell by the way that sounds that that needle is about shot. LP. Yeah, I need to find a better copy of this record for my main stereo.
I've got you under my skin.
And yes, I think that's running a bit fast, but there's not really a whole lot I can do about that, short of filing down the motor capstan. Many of these kitty record players ran fast, and I think they did that on purpose to make the records sound more lively to a young child who'd be listening to them. Alright, 45. I think that speaker might have a little tear in it too, or some foreign matter is falling down in there and vibrating against the cone.
Let me tell you about a place I know. To get in, it don't take much dough.
Where you can really...
And last, a Kitty 78.
Pokey, 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 pokey. Where's he? Pokey, 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 pokey. Where's Pokey?
Where's that pokey little puppy?
The pokey little puppy.
Now, if that speaker wasn't riveted in place, I would pull it out and check it out really well, but really not in the mood to deal with rivets and then trying to reattach the thing. I don't know why they didn't just bolt those in. I mean, did they think that the speaker would never have to be replaced? No, they probably figured nobody would ever even have one of these repaired, because I mean, let's face it, these were about what, $14.95 back in the mid 60s. So short of unless a tube went bad or some similar problem, then, or a needle, most people just threw them away when something happened to them. And as far as the jake leg repair, I've seen a lot of jake leg repairs in my years of working on this kind of stuff. But I can safely say this is the first time I've ever seen a repair where somebody would use a zip tie to secure a wire to a power resistor that gets hot. I mean, that's a first. And hopefully a last. Alright, that's about all I've got for this record player. I will come up with a new stylus to put in here one day, and then that'll be it. But for what it is, it's working pretty good there. I'm pressing a Q-tip down in here. Yeah, that speaker actually sounds like it has a dragging voice coil, possibly because of an obstruction in the air gap. And why they didn't put a screen between the speaker and the motor board is beyond me. The way this is, it'd be very easy to drop some small foreign objects down in here that could wreak havoc, but that problem will be corrected on another day. I'm not really worried about that right now. Well, on second thought, I got it out, and there was an obstruction down in here. And once I got that removed, the voice coil seems to be free. So, looks like we can salvage this speaker, but we're going to have to bolt it back in because I don't have any rivets or anything like that. Hate to have to do that, but it is what it is. Well, I found 3 matching bolts, so I mounted the speaker in with those. And I got to dig around here somewhere and find another bolt to go in the 4th hole, although we're not in a big hurry for that. That's the one that the turntable hides, so that one doesn't necessarily have to be matching. And then I need to find a needle, and then we'll be good to go. I posted about this hack repair in a group that I'm in, and someone told me that instead of putting the filter capacitors here, and I should have spent 40 or 50 bucks and ordered a modern day reproduction electrolytic can capacitor and fixed it back like it was originally. And if I had to use radial capacitors under the chassis, I should have mounted the terminal strip right here. Well, this terminal strip, that would be a tight fit right there, so that's the reason it went here. And they mentioned that I shouldn't have installed the chassis isolation capacitor here because of possible noise pickup getting into the volume control. Well, in my opinion, you could have that anyway with the AC line right here on the switch, right next to the volume control, and that's why radio and record player manufacturers always specified in the instructions, if you get a hum in the audio, reverse the line plug. I'm surprised someone didn't get on me for not using an AC rated safety capacitor here, and I might have done that had I had any in stock, but I don't have any, and I wasn't going to order any for this, and this is still an improvement over what was in there originally. And I'm not going to order a $40 or $50 can type electrolytic capacitor to put in a record player that, even if I did sell it, I'd be doing good to get 30 or 35 bucks out of it, and that would be after I sat on it for 6 months. So you know, I appreciate the advice. Then I'm not going to change my way of doing things. I've been doing it this way for 30 plus years, and it's worked for me. And after all, we're dealing with a kiddie phonograph here. We're not dealing with a high-end piece of audio equipment. If a little hum gets into the grid of the output tube, then I don't think most people would even notice. In fact, these things were not well shielded to begin with. It was a $14.95 kiddie phonograph. Alright, let's put the cover back on and put this thing back together. But, you know, if this was some kind of high dollar collector piece, then maybe I would have ordered an appropriate type can capacitor to use in it, but not in something like this. This is one of those instances where I just want to get it to play and have it look somewhat neat, not have it look like a total hack job like what I found. And I think we've accomplished that. So, you know, I appreciate the constructive criticism, but as long as it works and as long as there's not a danger of a fire hazard or a shock hazard, then that's really all I'm worried about. And someone expressed concern about this hot resistor baking these capacitors. Well, yes, that resistor does get hot, but it doesn't get as hot as some. It's a 2-watt resistor. It still gets too hot to have a piece of hookup wire zip tied to it, but I really don't think there's any danger of these capacitors getting baked under here. No more danger than this capacitor here getting baked from heat radiating from this output tube, and this cover does have ventilation holes in it, so I think we'll be okay. And by me talking about if I decided to sell this, I'd be doing good to get 30 or 35 bucks out of it. And that reminds me of a story that happened to me whenever I was in my late teens. You'll get a laugh out of this. Just shows you how some people can be. This guy found out about me somehow, and he came over here with a Lionel Spear Tone record player. About the same build quality as this one, typical one tube Wonder Kitty phonograph. And he proceeds to tell me his story of woe. Yeah, I bought this at an antique mall for $85. I needed something to play my 78s on, and I got it home and it don't work. And I'm thinking to myself, gee, imagine that. You should have tested it before you paid $85 for it. So at the moment I felt a bit sorry for him, so I opened it up and briefly checked it out while he watched me. And just about everything that was wrong, that could be wrong, was wrong. The audio output transformer had an open primary winding. The filter capacitor, I could look at it and tell it was shot. The cartridge was all corroded and dead. And the drive mechanism needed the usual work. Well, at that time, phono parts weren't as high priced as they are today, and I had a bunch of stuff in my junk box that I had salvaged out of various things that I'd parted out. And I offered to fix it for him for, trying to remember what I told him, 20 or 25 bucks, 30 bucks, I don't remember. Oh no, that's highway robbery. I'm not putting that kind of money in this thing. That's a rip-off price. Well, with that attitude, what I should have done at that moment was just showed him the door and been done with him, but I kept on. I said, okay, well, I've got something up here you might want, and I had I don't know, an Electrophonic or a Juliet or Lloyd's or some kind of all-in-one 70 system, you know, the typical variety that had the AM/FM radio and the 8-track player and the 3-speed BSR record changer and a couple of small wooden cased bookshelf speakers. And I said, I've got this. It plays 78s. It's been serviced. It's ready to go. You can have it for 35 bucks. Oh no, no, no. I'm not doing that. That's a ridiculous price. I'm not putting that kind of money in that. Well, at this point, I'd about had enough, and I said, so let me get this straight. And by the way, this is one of the few times I've ever gotten snippy with someone bringing me something to work on or wanting to buy something or whatever. I usually just roll with it and just get rid of them. But I said in a very snippy tone of voice, I said, let me get this straight. So you go to an antique mall and you pay $85 for some piece of junk record player that's not worth $10, and you bring it over here and you think my price to repair it, 25 bucks, is a ripoff. And then whenever I try to sell you something that actually works for 35 bucks, you think that's a ripoff. I said, I can't help you. You get your piece of junk and get out of my shop with it. I said, I don't have time to fool with you, and you can just take your piece of junk record player and get out of here. And he left in a huff, and that was that. Personally, I took it as a slap in the face, if you want to be honest with you. Don't come over here telling me that you paid $85 for something but you think my prices are a rip-off, and you expect me to cover your stupidity for nothing. It don't work that way. I can tell you what, if I put this on Facebook Marketplace for 85 bucks, even though it's been more or less overhauled, it'd sit there until Hades froze over before somebody came and bought it.
When you're blue, that way I can be close to you from the start.
Alright, there you go. Except for replacing the needle, this one's ready to go as far as I'm concerned. So, hope you got something out of this, maybe a laugh or two, and more to come later. And by the way, that's it with it wide open. That's about the amount of hum I would normally get from an amplifier like this. So let's flip the plug around and see if it about the same either way. Except for my outlet that doesn't want to make good contact here. I've been saying for 20 years that I need to replace these outlets in this thing, but I just never have done it yet. So yeah, like I said, that's the hum we're getting with it wide open, which is about what these things exhibit anyway, and you're not going to hear that over the record playing, so no big deal at all there. Alright, enough blabbering on. More to come at a later date.